What if we switch to solar energy completely? On an average, per house requirement of electricity would need 10 to 50 solar panels, which is very costly, and one solar panel requires approximately 1.6 square meters. That means we need much larger space to be able to generate the required amount of energy. Imagine how much space would be required for the requirement of the whole world. And also, solar panels just can't be put anywhere. It should be put in areas with sufficient sunlight. So, these brings certain limitations as where and how should these be installed. But what if we choose large enough open space where there is lot of sunlight every single day with little or no clouds? What about the largest hot desert, the Sahara? It seems perfect. Sahara is approximately 9.2 million square kilometers. It could accommodate 4 times as many panels as our present requirement if covered fully. This will generate 79 terawatts of energy per year. But problem will be in the transportation of energy. Also, sand being light colored reflects much of sunlight back, and now when we cover this with dark colored solar panels, this would increase the ground's temperature and leading to warmer air rising up, condensing with cooler air and then coming back down as rainfall. Eventually, this will turn this hot, arid area to savanna or even blooming garden. So, this idea of covering with solar panels seems good just on paper. And now, do you know what connects Earth's largest, hottest desert to its largest tropical rainforest, the Amazon Basin? The Sahara Desert is one of the least hospitable climates on Earth. Its barren plateaus, rocky peaks, and shifting sands envelop the northern third of Africa, which sees very little rain, vegetation, and life. Meanwhile, across the Atlantic Ocean thrives the world's largest rainforest. The lush, vibrant Amazon basin, located in northeast South America, supports a vast network of unparalleled ecological diversity. So, what do these seemingly different climates have in common? They are intimately connected by a 10,000-mile long intermittent atmospheric river of dust. Every year, intense Saharan winds send enormous clouds of dust on a transatlantic journey to the Amazon basin. This dust originates mostly from ancient lake bed in Chad and is rich in phosphorus. When it reaches the rainforest, the remains of long dead organisms of the Sahara provide crucial nutrients to the rainforest living flora. Phosphorus, which is essential to plant growth, is in short supply in the Amazon. Desert dust dumped into the forest every year helps in maintaining the balance. The data shows that of the 182 million tons of dust that leave the Sahara each year, 27.7 million tons, or 15% of the total, are scattered over the Amazon basin. The Sahel is the ecoclimatic and biogeographic realm of transition in Africa between the Sahara to the north and the Sudanian savanna to the south. It is found that there is a connection between rainfall in the Sahel and the amount of dust transported over the Atlantic. When rainfall in the Sahel is higher, the volume of dust is lower. It's possible that the increased rainfall could cause more vegetation to grow in the Sahel, thus leaving less sand exposed to powerful winds. Another possibility centers on the wind. The amount of rainfall is correlated with wind patterns that can sweep dust from the Sahara and the Sahel into the upper atmosphere, which is basically a superhighway to the Amazon. So, this means that Sahara being green will adversely affect the world's largest tropical rainforest. So, thank you for watching this.